Alright guys, so here's a little video talking through the quiz and giving you some further explanations for all the little problems. So question number 1, the key was really looking up the Ka values. So the Ka values will tell you right away the relative strengths of different acids, especially weak acids. So here I've looked up the Ka for acetic acid, cyanic acid, and HF just off of our chart from the equation sheet, and this is the smallest value. 10 to the minus 5th is the smallest value. 6.8 times 10 to the minus 4th, this is the largest value. So the larger the Ka, the stronger the acid will be. Again, keep in mind why that is. Why does this larger Ka value, why does that mean that the acid is stronger? Well, that's because it means that there's more products. The products are H plus and conjugate base, so more products means stronger acid, which will lead to a larger Ka. For number 2, I think people got confused about pH be the lowest or pH be the highest on version B. For pH being the lowest, that means that there's the most H plus, or another way to say it would be the highest concentration of H plus is going to give you the lowest pH, right? Low pH means acidic, high pH means basic. So in each one of these beakers, what's sort of meant to be shown here is we've got HCl in these two beakers and we've got HF in these two beakers. So HCl is a strong acid, HF is a weak acid. So out of all 4 of these, well, if we're looking for the lowest pH, we're going to narrow it down to these two right away. And then within these 2 beakers, it's indicated that there's equal moles but a smaller volume in case 1. So this would be the most concentrated H plus solution, therefore giving the lowest pH. So for this version, version A is the correct answer. In version B, we ask for the highest pH. So in version B, it's just going to be beaker 4, because again, we've got the weakest acid and we've got the biggest volume. So version B, the correct answer is 4 or D. For number 3, 2 common mistakes I think people made was not realizing or not taking into account the fact that this is a 1 to 2 molar ratio here between the barium hydroxide, and 2 moles of OH minus will be given off. So to find the concentration of OH minus, that's 2 times 0.0038 or 0.0076. The other problem that people ran into is that the question is asking for hydronium ion concentration, not hydroxide ion concentration. So to find hydronium ion concentration, I can take 1 times 10 to the minus 14th divided by 0.0076. That gives me my hydronium ion concentration. You could also have done sort of like a POH, pH treatment. That's essentially what we're doing here. This is just a sort of shortcut way to do that. But if you had solved for the POH, then done 14 minus that to find the pH, then found H plus from that, you would get the same answer here. For number 4, again, a lot of people miss this question, and this one I'm not really sure why. The definition of conjugate acid-base pair is that they only differ by H plus, right? So we've actually got 2 conjugate acid-base pairs here, water and OH minus. Those only differ by H plus. And HPO4 2 minus and H2PO4, those only differ by H plus. So then the trick is just sort of figuring out which one of these words have them written out properly. So C here, H2O is an acid, and OH minus is its conjugate base. That is the correct answer. D, we've got a conjugate acid-base pair, HPO4 and H2PO4, but here I'm saying HPO4 is an acid, and H2PO4 is the conjugate base, so that's incorrect, right? I've got those switched around. HPO4 would be the base, H2PO4 would be the acid in that case. So C in this case, H2O is an acid, and OH minus is the conjugate base. On the back side, so I'm just going to be talking about the multiple choice questions. If you do have questions about the short answer, just let me know, and we can go over those. The trick for number 5, I shouldn't say trick, but the way to solve number 5 is to realize that we've got a strong base and a strong acid. I've got equal moles of those, so those are going to neutralize. Those are going to react with one another, right? OH minus plus H plus, that's going to react to form water. We're going to neutralize that solution. So I think a lot of you probably ended up putting 0 molar for A, but what I want you to keep in mind is that autoionization reaction is always occurring in the background, right? I feel like I've been harping on that all quarter, so anytime we've got a water solution, that autoionization reaction is going to be occurring, so we will have 1 times 10 to the minus 7th molar H plus in our solution. So B, for this version, that is the correct answer. All right, let me know if you guys have any other questions.